Have you ever thought about what happens when your greatest success is also your biggest threat? Today, we're diving into the story of a database that was born from exactly that kind of crisis, right inside Facebook. It's a system so radical, they named it after a mythological prophet whose predictions, while always true, were never actually believed. This is the story of Cassandra. So our story really kicks off with a question that every developer, every creator, both dreams of and honestly kind of fears. You launch a new feature and it doesn't just do well, it goes viral. It's a massive runaway success. So successful, in fact, that it's about to bring your entire platform crashing down. What do you do? Well, that exact nightmare scenario, that was Facebook's reality, way back in 2007. The company wasn't just growing, it was absolutely exploding. We're talking hundreds of thousands of new users every single day. And its technology, well, its technology was struggling just to keep the lights on. The whole crisis really came to a head because of a single feature, something that seems so simple to us today but was pretty revolutionary at the time, being able to search your own inbox. For the very first time, users could search their entire message history. And people loved it. They used it constantly. The problem was, the databases that were powering Facebook, they just weren't built for this. They were designed for nice, predictable, structured data, and they were completely buckling under the pressure of indexing billions upon billions of messages. This wasn't a problem they could just fix with the tools they had. They had to invent something totally new. And the solution was driven by two engineers, Avinash Lakshman and Prashant Malik. Now, this is a really crucial detail. Lakshman wasn't new to this game. At his last job over at Amazon, he'd actually co-created Dynamo, another database built to handle the insane scale of a global retail empire. So he didn't just understand the problem, he had literally solved a version of it before. So what they built wasn't just some quick fix for Facebook's inbox. It actually became a cornerstone of this radical new movement in technology called NoSQL. It was basically a rejection of the old, rigid rules of databases, all in favor of flexibility and just massive, massive scale. They called it Cassandra, after the Greek prophet who was cursed to see the future but never be believed. And that name, it was absolutely perfect. Cassandra's design was so different from everything else at the time that a lot of engineers were really skeptical. It pretty much broke all the established rules. But here's what happened next, and it's almost as remarkable as the tech itself. Facebook didn't hoard this new invention. Just a year after they built it, they gave it away, open sourcing it for anyone in the world to use. And within just 3 years, it was adopted by the Apache Software Foundation, cementing its place as a true pillar of modern data infrastructure. So what was this big, radical idea? Well, for decades, if you needed more database power, you basically had one option. Go buy a bigger, more powerful, and way more expensive server. We call this scaling up. Cassandra just completely flipped that idea on its head. Instead of one giant, expensive machine, it asked, why not use dozens or even hundreds of cheaper, off-the-shelf servers? This is called scaling out, and it's pretty much the philosophy that powers the entire modern internet. But, okay, scaling out like that creates a whole new problem, right? What happens when one of those hundreds of servers just fails? Well, Cassandra's architecture was designed from the ground up with this kind of chaos in mind. Its goal wasn't just scale, it was resilience. And this is where the real genius is. The key insight, the absolute magic trick, is that Cassandra has no boss. In a traditional system, you have one master server that coordinates everything. If that master goes down, your whole system can collapse. But in Cassandra, every server or node is an equal. They all work as peers. If one node goes offline, the others just pick up the slack. There is no single point of failure. It's designed to survive. So how does it pull this off without a boss telling everyone what to do? Well, it uses a couple of brilliant techniques. First, to spread the data out, it uses something called consistent hashing. Just think of it like a super smart librarian who instantly knows exactly which shelf to put a new book on without ever having to look at a central catalog. And second, for writing new data, it uses something called LSM trees. Instead of slowly and carefully finding the perfect place to insert new data, it just quickly writes it to a log, like adding a quick note to the end of a list, and then sorts it all out later. This makes writing new information unbelievably fast. Now, this whole design philosophy forces you to make a fundamental trade-off that every single large-scale system has to deal with. It's known as the CAP theorem, and you can think of it like a law of physics for distributed data. It says you can have 3 guarantees, but you can only ever pick 2. And Cassandra made its choice loud and clear. It chose to always be available, even if parts of the network get messy and can't talk to each other. Now, this comes at the cost of what we call immediate consistency. Basically, it was designed to always be online, even if that means for a split second, your new profile picture might show up in New York before it does in London. And for most internet applications, you know what? That trade-off is absolutely worth it. And that one single choice to prioritize being always on is the exact reason Cassandra became the invisible backbone for some of the biggest services we use every day. A huge turning point came in 2011 with the introduction of CQL, or the Cassandra Query Language. This was a game changer because all of a sudden, developers didn't need to learn some strange new way to talk to the database. It looked and felt just like SQL, the language they already knew and loved. This made Cassandra dramatically easier for thousands of engineers to start using. And the adoption was just staggering. The next time you binge watch a show on Netflix, scroll through your Instagram feed, use an Apple service, or book an Uber, just remember this. There is a very, very good chance that Cassandra's masterless, always-on architecture is humming away in the background, making it all possible. But of course, the story didn't just end there. The internet's demands for scale and resilience have only gotten bigger and crazier, and Cassandra has continued to evolve right alongside them. The Cassandra of today is even more robust. It's added features like zero downtime upgrades, meaning services can actually be improved without ever going offline. And it has deep integrations with modern cloud technologies like Kubernetes. It really continues to be a go-to solution for anyone building at a truly global scale. So that leaves us with this. Cassandra was born to solve a problem of massive scale way back in 2007. But as our entire world becomes completely reliant on 24/7 services, everything from finance to communication, the question it first tried to answer is now more urgent than ever. How do we engineer a world that, quite literally, cannot be allowed to fail?